Hello, welcome back to my YouTube channel, and thank you for tuning in. So today I'm bringing you math, and I want us to solve for the value of m and n, given that we have 9 to the power of m minus 4 to the power of n is equals to 17. So I'll begin by 9. I can write it as 3 squared, all this to the power of m, minus 2 to the power of 2. This is now 4. All this to the power of n is equals to 17. So according to this rule, the exchange rule, where we exchanged our exponents, we have a to the power of m, all this to the power of n is the same as writing a to the power of m, all this to the power of m. So we are going to use this formula here. 3 to the power of m, all this to the power of 2, minus 2 to the power of n, all this to the power of 2 is equals to 17, right? Next step, you can see this is the difference of two squares. We have a square minus b square is the same as a plus b into bracket a minus b into bracket. So this is the difference of two square, whereby our a here, a is 3 to the power of m. 3 to the power of m is our a, and our b is 2 to the power of n. 2 to the power of n is our b. So I want us to write it in this form. So this will be 3 to the power of m plus 2 to the power of n into bracket 3 to the power of m minus 2 to the power of n, close the bracket. So if you can realize, 3 to the power of m plus 2 to the power of n is greater than 3 to the power of m minus 2 to the power of n. So this is the smallest, and they are all odd factors. Odd factor. So 3 to the power of m minus 2 to the power of m is our smallest, and this is all this to the power, all this is equals to 17. So we will look for the factors of 17, which is 17 times 1 or 1 times 17. So these are the factors of 17, and these are odd factors, and 3 to the power of m plus 2 to the power of m is the greatest. So we will equate the greatest factor with the greatest factor and the smallest factor with the smallest factor. This is what I mean. 3 to the power of m plus 2 to the power of n is equals to 17, and 3 to the power of m minus 2 to the power of n is equals to 1. Okay, so you can realize if we add the two, we can solve, or we can find the value of m or n. So let us add the two to get the value of m. This will be 3m plus 2n is equals to 17. I'm adding 3m minus 2n is equals to 1. So let us add. So 2n plus negative 2n, this will cancel because it's 0. So 17 plus 18, 17 plus 8 plus 1 is 18. 17 plus 1 is 18 is equals to 3m plus 3m. This is 3m. 3 to the power of m. So 3 to the power of m, there are 2 we are adding. So I want us to remain with m. I'll divide here by 2 and also divide on this side by 2. So these 2 will cancel. 3 to the power of m is equals to 9. 18 divided by 2 is 9. I want to make my bases the same so that I can get the value of m. This is what I mean. 3 to the power of m is equals to 3 to the power of 2 squared. I can equate my exponents. M is equals to 2 This is the value of m. We can now find the value of n. So let us come on this side and substitute in this equation here to get the value of n. M is equals to 2. So 3 to the power of 2 minus 2n is equals to 1. 3 to the power of 2 or 3 squared is 9 minus 2 to the power of n is equals to 1. 9 subtract 1 is equals to 2 to the power of n. 8 is equals to 2 to the power of n. I want to make my bases the same. This is 2 to the power of 3 is equals to 2 to the power of n. So bases are the same, equate the powers. 3 is equals to n, which is the same as n is equals to 3. So our values are m is equals to 2 and n is equals to 3. So let us check and confirm if they satisfy our equation. So let me rewrite our equation. Our equation was 9 to the power of m minus 4 to the power of n is equals to 17. We have 9 to the power of 2, this is m, minus 4 to the power of n, which is 3, is equals to 17. 9 to the power of 2, 9 squared is 81 minus 64 here is equals to 17. 81 minus 64, it's 17. Is equals to 17. Our left hand side and our right hand side are the same. So